We announced it publicly at our conference last month. There's been a lot of downloads of it from the Clang website, and we know that there's been thousands of leaks found because they're very structured and very easy to find. So I'll just close with some implementation details. So why on earth are we analyzing source code, right? We have the LLVM IR, right? I mean, it's this fairly rich, low-level IR that has a lot of information, but it removes a lot of the other high-level guck that we might not care about. Well, the problem is that when we're finding bugs, you actually care about a lot of that high-level information. The first thing is that the point of all this is not to generate machine code, but to generate meaningful information that a user could use to actually go and fix a problem. If they don't know how to fix it, it's completely useless. And so we actually need all that rich source level information. We need information about macros. They need to know where the problem actually occurred, what file it occurred. At the LLVM level, all that is gone. And now, hypothetically, you can go and maybe correlate some of the debug information by analyzing LLVM IR. But it's just really hard and gets intractable very easily. The other thing is the compiler makes a lot of decisions when it lowers things like for loops and function calls down to LLVM. The order evaluation of expressions can change and so forth. And so if you really wanted to check for portability of your code, you can let the static analyzer actually make those decisions very lazily and say, I'm going to check all permutations in which you use something. So you can get a much more systematic checking of your code. You can't recover that after it's gone. So where does this reside? Steve showed this figure earlier today. So basically all resides in the analysis library, which is really supposed to be a toolbox to provide a base solver for doing data flow analysis and so forth, and also these checks. It's not highlighted, but we also use the rewriter to do those HTML diagnostics. Steve mentioned the rewrite library earlier for doing an Objective-C to C translation. But the way we actually generate those HTMLs, we just take the source code and insert HTML tags. We know exactly the extent of all the tokens and expressions and so forth, so we can just slam the syntax highlighting right in there, including the things for macros and so forth. So what does libanalysis consist of right now? It consists of some source level control flow graphs, so essentially the equivalent of the LLVM IR, but at a source level. And so things like ternary operators, short circuit operations, these are explicitly represented at that level as well. We have a flow-sensitive data flow solver, so you can do things like live variable analysis and initialize values, the basic checks that you would want to do in a compiler, but now you can do it at the source level. We have a path-sensitive data flow engine, which we've implemented on top of it, this memory leak checker. But it also, just as part of tracking values for paths, can find things like null dereferences, those stack errors, and so forth. And we think as we track more and more information, we'll be able to find buffer overruns. They'll just fall out from that basic value tracking. And we've also implemented a lot of different checks. Dead store checking, which depends on live variables, which can identify some insidious dead code, and a lot of basic API checks. And I want to comment is that implementing these is actually fairly simple. And so if you're interested in implementing your own checks, although you have to use the Clang APIs at this point, eventually we'd like to make it more scriptable so that you could express these checks even in a higher order thing like JavaScript. And the last interesting thing is that the static analyzer doesn't know that it's rendering to HTML. We have a separated interface for reporting bugs from actually generating them. And that's using essentially this diagnostic client interface. And it's basically implements a view of the bug reports. So instead of having HTML, instead we could generate maybe directly to an IDE or some other database or something like that. And so looking forward, there's a lot we want to do. We want to be able to continue to enrich the diagnostics. I'd like to do interprocedural analysis or start baking it over the next year. Implement a lot of checks. Add the ability for people to easily extend the system without understanding all the core guts of the analyzer. And have a lot more different kinds of analysis engines since there isn't just one way to do program analysis. And for more information, if you're interested in checking it out, go to clang.llvm.org. Some questions?
pattern and medium checker analysis, so it's hard coded, look at each path and source and intermediate ASP or.
Well, you do. Well, you can do both a combination of syntactic and semantics checks. Basically, say when the engine tracks basically like the state that you're in along a current path, and then let's say you want to check every time I call a specific function that there's not null or whatever. You actually interrogate what's the value of the expression being passed in.
So you're basically doing code, not some kind of formal declaration.
That's correct. That's correct. But the idea is that we'd be able to, with the scriptability, is have different ways to express that, have it dynamically loaded in, and so forth. But right now, it's hard-coded as checks. Yeah.
Are you looking at essentially enabling removing bound on how much work is done for kind of like a final check situation? Or
that's a flag right now.
Okay, so you can actually I'll let it run as long as it takes.
We haven't added it to the command line, but we can do that. It's literally just a value that you set in the API.
Any work on parallelizing?
That's right. Sorry. So the idea was, can you tell the analyzer essentially to remove the bound on how much work you can? And I said that that's completely API specifiable, so you can let it run for as long as you want.
Is there any work to parallelize the analysis?
Exactly. So the analysis is based on using a lot of functional. So the question was, is there any work on parallelizing analysis? A lot of the analyzer is built on using functional data structures, so it's inherently designed to be parallelizable. And actually, there's a lot of data structures that we added to LLVM, like an immutable map, an immutable set. They're very much inspired from Lisp and OCaml for doing functional data structures. Yes. Yeah. Yes, when you see an assertion, when it sees an assertion, it assumes that condition. If it can't prove that a condition is true, it'll assume that if the assertion succeeds, it'll pick up those constraints. Yeah. Yes.
So I was looking at your examples, and they're all pretty simple.
Yes.
I was wondering if you traded on some non-trivial pathological C sources.
So there's a lot of things we've traded on here that I can't. So we've run it over PostgreSQL. So those numbers we had earlier today, we've run it over Nmap.